All right, so I'm going to do, let's see here. I don't think that's the beginning. Pre-co. I'm going to do this proof, number 9. When it stops, a little laggy. I'm going to do number 28, and I'm going to do number 12. Okay, so if you wanted to see those, this is going to be good for you. So we bailed you out. We marked the diagram for you. Make sure that you mark the diagram, though. Here we go. LOM, so that's my first statement. Angle LOM is congruent to angle NPM, all capital letters. That's a given. So I want you to mark your diagram, even though we did it already. LOM and NPM. LOM is there, NPM is there. We could have called it angle O and angle P as well. We're going to say LM is congruent to NM for the same reason. Right? That was given, that was given. So we can go ahead and say those two are congruent. So now we either need another side somewhere or we need another angle because we only have an angle on the side. Here's our angle, here's our side. I'm going to say this angle here is congruent to this angle here. So we're going to say LMO is congruent to NMP because if vertical, then congruent. And then finally, so that gives us angle, angle, side. There's another side. So these aren't in the right order right now. It's angle, side, angle. The side is excluded from the angles. It's not included. So that's why it's going to be angle, angle, side. So triangle LOM is congruent to triangle NPM by angle, angle, side. Okay. Let's try this one. Ooh, this one's a little bit better. So GK bisects angle. So angle JGM. That's why we worked so hard on this bisect stuff earlier. So JGM, that's this angle right here, JGM. So we're going to say from that, we can get angle JGK is congruent to KGM. Because if bisect, then congruent. So I can mark those two congruent to each other. They told me that GJ is congruent to GM because that was a given. Mark your diagram. And now we have an angle and a side. We need something else. So if you look here, whenever you have a diagram like this, you're going to have the reflexive property. You don't have to use it, but here actually we do have to use it. GK is congruent to itself. And that gives us our third and final side. So that's called the reflexive property. So now let's just make sure we said congruence. Did I say I have an angle? I said an angle was congruent. I said a segment was congruent. And I said another segment was congruent. Oh no. Angle, money, money. So again, you have to think about, is the side or angle included or excluded? So is this angle included? Side, angle, side. Yes, it's included. So the angle is going to go in the middle. Angle GJK is congruent to, triangle. Triangle. GJK is congruent to GMK. All capital letters by side, angle, side. So far, 4 minutes. We got one more to do. GM bisects. So let's do this one. JM. John Mayer bisects angle KLJ. KLJ. Nope. Double check. KJL. KJL. So that angle is being bisected. That's a given. Now we can say that from that bisect, again, we didn't say anything was congruent. A lot of people are going to mark this congruent. They're going to know what they're doing. They're going to move on. But you didn't say they were congruent. So make sure you say in your proof that they're congruent. Angle, let's see if I can get the letters right. JKM, all capitals, are congruent to or is congruent to angle LJM, all capitals, because if bisect, then congruent. So use that given. Now let's use the next one. John Mayer is perpendicular to Kelly L, KL. Who has initials KL? Chloe. I should think the last name first. Lightfoot. Lori Light. No. Can't do it. Not fast enough. So if you look here, we have the box. Don't let them trick you with this picture, right? We know two angles have to be right. So we know that angle JMK and angle JML are right. Because if perp, this is given. If perp, then right. So don't fall into this trap. Don't put the box there and move on and say angle, side, angle. Right? Don't do that quite yet. Did you say that this angle is congruent to this angle? You said they're both right, but you need to make that connection. You need to make the congruence connection. Undo, undo. So let's do that connection real quick. Angle JMK. And there's a couple ways to do this, but I'll just do it the easiest way. JML. Because if right, then congruent. Notice here I said right. I didn't say that they were 90 because that's not the definition. You say they're 90, you're on the right track. Your understanding can be sharpened for sure. So I have this angle congruent to this angle. I have this angle congruent to this angle. In order to prove triangles congruent, I need a side. I need a side. So there's a couple other steps you can do. The easiest one I would do is I would say John Mayer is congruent to itself because of the reflexive property. I don't know why I changed colors. Mark your diagram. People that are successful in geometry, mark their diagram. People that are not successful, don't. Let's go back to the purple. Let's finish the purple. So let's make sure I have, so I said I have a side congruent here. I said another side was congruent, or an angle, excuse me, was congruent here. Here I had they were right, so I didn't get anything congruent. Here I had they were perpendicular, didn't get anything congruent. Oh, here it is. I have another angle. So now, is it angle, angle, side, or is it angle, side, angle? When you look at it, you know that the side is included because it's touching both angles. So it's going to be angle, side, angle. Triangle KLM is congruent to triangle LJM because of angle, side, angle. KL. Kristen, Kevin Feder, no, some important Kevins. Craig, no, let's see. Kiefer. No, I can't do it. I can't do it. Sorry. Spent a minute. I wasted your minute. I wasted a time. I wasted a minute of your time. I'll record the video again. Peace.